Started recording.
Yeah, I started just now.
Okay.
Yes. So can we
Madam,
start now?
Madam, chapter 1 will be taken care of that after some time, madam.
Chapter 1. Yeah. Just a moment. I will check the.
Chapter energy scenario.
No. Who is going to take chapter 1? I'm just looking for that. Just a moment.
Maybe Asmita, madam.
Just a minute, sir. Actually, I have that. I'm just
Okay.
opening.
After 5 minutes, I will leave, madam.
Yes, sir. Yeah, sure.
Yeah.
So, can I start now?
Yes, madam.
Yeah. Just a minute. I will share my screen so that we can find easily. Actually, it's Chapter 1, Book 1, Energy Scenario. It's tomorrow, sir, Sunday, 27th of July. Asmita, madam. Second, Asmita, madam. Asmita Marathe, madam. She's going to take first lecture, Energy Scenario. Satyanarayan, sir. Asmita, madam, is going to take Energy Scenario, first
Yes,
chapter.
madam. Okay,
Yeah,
madam.
tomorrow
Thank
morning.
you.
Yeah.
Yes, madam.
Thank you. Okay, so I'm sharing my screen so that we can start. Okay. So the chapter is Energy Management and Audit. Okay, as Chavan sir told, and also the Gande sir is stressing out that we need to first clear this exam, and it's very important to clear this exam. According to, if you see the patterns, previous exam papers, then you can analyze all the questions, whether it's MCQ problems or theoretical questions. You will see the similar pattern in the questions. Okay. After concluding this session, fourth chapter, Energy Management and Audit, I'm going to show you how each and every part of this topic, or any of the topic, or any of the book, is how much important to clear this exam. Okay, I have one example. I have downloaded the latest paper of 23rd NC exam for the first paper, and I can show you how the very small thing. It may be very small thing in the chapter that is to be reflected in the MCQ either, or in the short or long answer type questions. Okay. So let's start with the fourth chapter. It's what it contains. So it contains the definition of energy audit and energy management. What are the needs for doing these activities, and what are the types of energy audits? Then the approaches to the energy audits, and the cost of the energy. Benchmarking is nothing but the target setting. You are going to set the target for your energy consumption. So this is nothing but the benchmarking. And I want to highlight here the one point. Benchmarking, this topic is very important in case of short answer question. Okay. Many times it is asked in examination, benchmarking. What is benchmarking? And you need to explain it with some example. Then matching the energy use to requirement, maximizing the system efficiencies, optimizing the input energy requirements, fuel and energy substitutions, and energy audit instruments and metering. It is very important part. Again, just now, what I told you is the benchmarking. It is asked many times for the 5 marks. So similarly, energy audit instruments and metering. This question is also asked in the latest examination, 23rd NCE. They are going to ask you the question like match the pairs. You need to match the pairs. That means they are going to give you some instrument and ask what quantity they are going to measure. Like power analyzer is used to measure any power quality like kVAs or kilowatts or voltage or current. Similarly, or you can say stroboscope. So it is used to measure the speed. So you just need to match the what quantity the meters are going to measure, instruments are going to measure, and you will get the 5 marks for that. Okay. And then manner and intervals of EA regulations. So each and every point is very important. So let us start with the first point. So everyone is here. So can I start now first?
Yes,
Hello?
madam, you can start, madam.
Yeah.
Yes, you can start.
So first point is
Yes,
definition
ma'am.
and okay, sure. Yes, thank you. So the definition and objective of the energy management. So what do you mean by energy management? This is the very first and basic question in this chapter. So the fundamental goal of energy management is to produce goods and provide services with the least cost. So always in any industry, whenever we go, we always focus on the cost. Right. Even nowadays, renewable energy, more specifically solar energy, everyone is inclined to install the solar, whether it is open access, PPA, group captive, or rooftop. It's to save the money which they are spending on the energy, right? So the fundamental goal of the energy management is to produce the goods. We are not stopping the production of goods. We are producing goods with optimum use of energy. Right, we are using the services, but with optimum use, thereby we are reducing the cost of the energy. So the main focus for the energy management, or main intention of the energy management, is to reduce the cost which we are spending on the energy, not reducing the production. We need to increase the production, but we need to reduce the cost which we are spending on that. So the judicious and effective use of energy to maximize the profits, minimize the cost, and enhance the competitive positions. So the definition of energy management is judicious. That means you need to use your energy perfectly and effectively to maximize your profits by increasing the production, but minimizing the cost. So cost you can minimize in case of energy. If you use your energy with optimization, whatever you required by reducing the wastage of the energy, then you can minimize the cost of production and enhance the competitive positions. Or the another definition is the strategy of adjusting and optimizing energy using systems and procedures so as to reduce the energy requirements per unit of output, holding the constant or reducing total cost of producing the output from these systems. Now I just want to add one point here. So every line which is mentioned in this book is very important because as Chavan sir told that 50 marks are for MCQs. So MCQs are taken from these lines only. Okay. So if you read these lines carefully, then you can definitely answer any of the MCQ which is asked in the examination. Okay. So every line is important. Every table which contains the values, it is very important from short answer question type and for the MCQs also. Okay. Then the objectives of the energy management. What are the objectives of energy management? Why we need energy management? So to achieve and maintain the optimum energy procurement and utilization throughout the organization. Okay. To minimize the energy cost, waste without affecting the production and quality. Right. Just now we discussed about it. We need to maximize the profit, but with minimum cost. We are not reducing the production. We are not affecting the production and quality of the product, but we are reducing the waste. That is nothing but the energy management. Okay. To minimize the environmental effects. So if we are discussing about the energy saving. So nowadays, everywhere ESG and the carbon footprints and carbon emissions, these are the buzzing words. So if you are managing the energy, that means you are reducing the use of energy. So for example, if we are using 1 unit of electrical energy, that means 1 kWh of electrical energy, that means we are emitting around 0.85 kg to 1.1 kg of CO2 in the environment, and it's terribly affecting our environment. So to protect our environment, we can save the energy, right? So you can imagine just 1 kilowatt hour, that means 1 unit of energy, if it's harming this much to the environment. So if you save 1 unit of energy, that means you are reducing the carbon emission by 0.85 kg of CO2. So the successful energy management must combine an effective strategy with the right practical action. Okay. So it begins with the key decision makers and then involves every employee on a day-to-day basis. So they are considering it is a facility or the industry where the right practical actions need to be taken, and every employee, right from the top management to the shop floor employee, everyone must follow the energy management policies, or they must try to manage the energy so that emissions will get reduced. They will reduce or minimize the cost of production and thereby increasing the quality. So the many organizations would like to save the energy, but to have the most impact and success, they need to give priority to energy management and make it an integral part of company management strategy. So next is energy definition, energy audit definition. Okay. So after completing this chapter, there is some MCQ. Right now, Gandhesh sir also taken the MCQs at the end of the chapter, right? So here also there are MCQs, 10 MCQs. So you will find out whatever we have reading here, whatever we are studying here or discussing, everything is there in the MCQs. Okay. So these definitions may also may also asked in the MCQ. So energy audit is the key to a systematic approach for decision making in the area of energy management. It attempts to balance the total energy inputs with its use and serves to identify all the energy streams in a facility. So it quantifies energy uses according to its discrete functions. Industrial energy audit is fundamental to the comprehensive energy management program and is defined in EC Act 2001. You just now studied about the Energy Conservation Act 2001 in the first session. So energy audit means nothing but the verification, monitoring, and analysis. Actually, I was in the lecture when Gandhesh sir taken the MCQs. So there is one MCQ which is asking energy about this. Energy audit means verification, monitoring, and analysis, and fourth option is, I think, timeline, time duration, something. So, hello.
Yeah, madam.
Yeah.
We are
Yeah,
listening.
we are audible. You are audible.
Okay. So the energy audit is nothing but the verification, monitoring, and analysis. So what does it mean? Verification means you have the data about the energy consumption. So you need to verify it. You just not verifying it, then you monitor it using some instruments. And then you are analyzing it. That means you are doing calculations and then provide the report. So all this practice is nothing but the energy auditing. That means you are first verifying the data with whatever you have. Then you monitor by using some instruments and then analyze the readings which you get from those instruments. And then you prepare the report with the complete calculation and with the energy conservation measures. It is nothing but the energy audit, including the submission of technical reports. So here they have also written. So energy audit means verification, monitoring, and analysis of use of energy, including submission of technical report containing recommendations, right? And that means energy conservation. What are the measures you can take? After the energy audit, you need to submit a report where the first page consists of executive summary. So executive summary shows what are the measures you are going to take to save your energy. For improving energy efficiency with cost benefit analysis and an action plan to reduce the energy consumption. So what are the energy efficiency measures you are going to take? After analyzing and after verifying, after monitoring, you need to all mention in your report, energy audit report, the action plan. That means you just not including there the energy conservation measures. You are including what should be the action plan to save the energy. And then the cost benefit analysis. Cost benefit analysis is very important in energy audit. So if you are providing some measures for energy saving or energy efficiency, so the facility to which you are providing energy audit service, he is going to ask you what will be the payback period and how I will get benefited by this retrofitting or by taking these actions to save the energy or to improve the energy efficiency. Okay. So what you need to remember is energy audit is nothing but the verification, monitoring, and analysis and the submission of technical report and recommendation with cost benefit analysis and action plan to reduce the energy consumption. The next is, what is the need for energy audit? So in any industry, the three top operating costs are often found to be energy. First, what are the three top cost the industry or the facility are bearing? First is energy, both electrical and thermal, then labor and material. So among the three, energy has the highest potential for the cost reduction, right? So it's in your hand. So you can save the energy, you can efficiently use the energy, and thereby you can reduce the cost which you are spending on the energy, whether it's electrical or thermal. So energy audit will help to understand more about the ways energy is used in the industry, and help in identifying the areas where waste can occur and where the scope for improvement exists. Such an audit program will review variations in the energy cost, availability, reliability of supply energy, and decide an appropriate energy mix. So appropriate energy mix is nothing but for example, for this energy mix, if you are every facility requires electrical energy and they are taking it from the DISCOMs. So nowadays, again, it's solar. So many of the industries are shifting to solar. They are using a mix of the energy as a renewable energy from the solar and from the DISCOM, right? So energy mix is nothing but, again, in energy audit, along with the what you say, energy saving measures, you need to provide solution with the energy mix. That means along with the DISCOM energy, you can go for the renewable energy so that you can save the cost which you are spending on the electrical energy. So identifying energy conservation technologies, retrofit for energy conservation equipment, etc. So retrofitting is also done, and it's under MEDA or BEE. So MEDA and BEE is continuously provide the solutions. That means they are promoting the retrofitting, like BLDC fans. Nowadays, conventional fans are replaced with the BLDC fan, which are more energy efficient, or Bachat lamp Yojana, just now you discussed with Gande sir. So LED lamps, before, previously it's CFL. Now LEDs, we are promoting LEDs to use so that you can save the energy. So wherever there is a old CFL or the incandescent you cannot see now, but lamps are there, they can be replaced by using the LED lamps and everything. So retrofitting for the energy conservation equipments. So the types of energy audit and its approach. The type of energy audit to be performed depend on the type of industry. Okay, so the depth to which final audit is needed and the potential and magnitude of cost reduction desired. So the type of energy, there are three types of energy. There are preliminary audit, then targeted audit and detailed audit. So three types of audits are there. So the type of which audit you are going to select, it depends on the industry and the depth to which the final audit is needed and the potential and magnitude of cost reduction desired. So thus the energy audit can be classified into following types: preliminary, targeted, and detailed audit. So preliminary audit is nothing but the walkthrough audit. So you are just going there and observing the things. That means without any measuring instrument, you are going there just by observation, whatever the flaws you are observing, you just note it down. You are taking their electricity bills and you are analyzing from that in electricity bills what are the problems and how they can save on their electricity bills. Okay, so preliminary energy audit is nothing but the walkthrough audit, or you can call it as diagnostic audit, and it is relatively quick exercise. It's very fast and uses existing or easily obtained data. Existing means you are collecting the data from facility itself. Facility records their data. You get that recorded data, and the audit is done. How? The scope of preliminary energy audit is to establish the energy consumption in the organization. So how your energy consumption is established in the organization. That means from the electricity bills. Here it is energy bills and invoices. not only electricity bills, fuel bills are also collected. Obtain the related data such as production for relating with energy consumption. Estimate the scope for energy savings. In case of preliminary audit, you are just observing. That means if you are walking through the facility and you see some CFLs are there or some old fans are there, you are just suggesting them that you can retrofit it by installing BLDC fans or by LED tube lights, batten lights, so that you can save this much amount of energy, and thereby you are saving the cost. So this is the walkthrough audit. So identify the most likely and easiest areas for attention. So for example, here they have mentioned it, unnecessary lighting. So somewhere then there is no need of lights continuously. Whenever there is a movement or whenever someone is going there, then only you need you require the lights. Then you suggest them, you can install the sensors so that you can save the energy. Higher temperature settings, leakages, etc., which you can observe by naked eyes. You did not require any special instrument for that. So that is involved in the preliminary audit, or you can call it as walkthrough audit. Then identify immediate improvements and savings. Okay, immediately you can, just now what I said, you can immediately told them that your compressed air is leaking somewhere. So you can say, you can suggest them that your compressed air is leaking through this pipe. So you can make some arrangements and save your compressed air and thereby energy. Set up a baseline or reference point for energy consumption. Identify the areas for more detailed study and measurements. So after the walkthrough audit, you will get to know what are the reference points for the energy consumption and what are the areas to which the facility or the industry must look into. Some examples of the no-cost energy management measures are arresting leaks. Like just now, we have discussed the example, right? Arresting the leaks, whether it's compressed air leak or the steam leak, then controlling the excess air, controlling the excess air to the boiler. Then some examples of low-cost energy management measures are shutting equipment when not needed. That means idle running. If motors are running idly, you must keep shut it down so that you can save the energy. Then replacement with appropriate lamps and luminaries, right? Just now I have told you that by walkthrough audit, you can immediately say that you can replace the CFLs or the old tube lights with the new batten lights or LEDs, or somewhere now you cannot find out those old electronic ballast. Those old ballast with the electronic ballast one for the tube lights. So replacement with the appropriate lamps and luminaries. Then the areas for detailed study and measurements. What should be the areas? So converting from direct to indirect steam heated equipment and recovery of condensate. Installing, upgrading installation on the equipment, whether if it is the thermal, then thermal energy, then you need to check the insulation of the equipment provided. Then the modifying process to reduce the steam demand, investigating scheduling of the process operations to reduce peak steam or water demands, and evaluating waste heat streams for potential waste heat recovery. If the streams like steams with a high temperature, they are going west, then you can recover that waste heat, right? Then next is targeted energy audits. Now, targeted energy audits often results from preliminary audits. Targeted means from the preliminary or the walkthrough audit, if you find out any of the certain area or certain department of the facility where the energy conservation is very much important, energy saving is possible, then you target that area only. Okay, so that is nothing but targeted energy audit. So they provide data and detailed analysis on specified target projects only. For example, an organization may target its lighting system. Okay, only somewhere they ask you for the walkthrough audit. after the walkthrough audit, if you suggest that you are spending more on the lighting system, then they ask us to target that area only. That means you must suggest us energy saving measures for the lighting system. So the targeted energy audit is nothing but an organization may target its lighting system or the boiler only, or steam system, or diesel generator only, or compressor only, with a view of effecting energy savings. So targeted audits therefore involve detailed survey. Now, in case of targeted audit, you are not going there only to observe the things. In targeted energy audits, you are going there with the proper instruments in that department or in that particular equipment, and you are doing actual detailed audit of that particular, you are doing detailed survey of that particular area, particular facility like compressor or lighting system or the boiler. Okay, so targeted audits therefore involve detailed surveys of target subjects and analysis of the energy flows and cost associated with the targets. Final outcome is the recommendations regarding actions to be taken. Again, the last output, you are going to get the recommendations after your analysis. You need to get with the proper solution, proper observation, and the analysis. Final outcome must be recommendations how to save the energy, how you are going to save by installing proper measures there. Then next is detailed energy audit. So detailed energy audit is a comprehensive audit and results in a detailed energy project implementation. So in case of detailed energy audit, basically detailed energy audit is a combination of walkthrough audit, targeted audit, and everything. It combines all. That means the first stage of the detailed audit is nothing but the walkthrough audit. You are going to check everything personal. You are going to gather your team for detailed audit. You are going to calculate how much time is it going to take. Then what is the process there, their flow chart. You are going to make everything in case of detailed energy audit. Okay. So what they have given here, detailed energy audit is a comprehensive audit and results in a detailed energy project implementation plan for a facility. Since it accounts for the energy use of all major equipments, it considers the interactive effects of various projects and offers the most accurate estimate of energy savings and cost. It includes detailed energy cost saving calculations and project implementation cost. Okay, so what they have mentioned here, detailed energy audit is a comprehensive audit and results in a detailed energy project implementation plan for facility. Since it accounts for the energy use of all major equipments, it considers the interactive effect of various projects and offers the most accurate estimation of energy saving. So one of the key elements in a detailed energy audit is the energy balance. This is based on an inventory of energy using system, assumptions of current operating conditions, measurements and calculations of energy use. So you are balancing the energy. That means what you are providing as an input and what you are getting at the output. You are balancing those energies at the input side and the output side. So detailed energy auditing is carried out in 3 phases. Again, the detailed energy audit is carried out in 3 phases. First is pre-audit, audit phase, and post-audit phase. So a comprehensive 10-step methodology for conducting detailed energy audit is suggested as follows. So 10-step methodology for conducting detailed audit. In this chapter, they have also provided the format for the report, format of the report of the detailed energy audit. So how you are going to make the report, what should be the contents in that report. So it's all mentioned in this chapter. Okay. So the plan of action and purpose. So there are 10 steps in the methodology for conducting detailed audits. So first step is plan and organize. So you need to establish your energy audit team first. Okay, so plan and organize. Then walk through audit. What is the organize the instruments and time frame is if you have already done the walkthrough audit in the facility. Hello, am I audible?
Yes, madam, you are
Yeah.
audible.
Yeah, you're audible.
Okay. Actually, there is a problem in my internet connection. I saw just now. Connection is okay. So plan and organize means you are first planning and organizing your energy audit team, then walkthrough audit. If you are going to do the walkthrough audit, then you get to know what are the processes there they are conducting. So you get to know what instruments you need to take there for conducting the detail audit for analysis purpose, right? So that's why here that they have mentioned result, organize instruments and time frame. What time, how much time will you require to complete the detailed audit, and the informal interview with the energy manager and production or plant manager. So this interview is required because they know what processes are they are doing on the daily basis. They have the data, they have the SLDs, they have the SLDs for the electrical distribution system, and if it is a thermal units, then they have all the drawings there, drawings with them. So you need to collect in the first stage all the basic data of the energy consumption, drawings, and everything. So then here they have written the macro data collection, right? Macro data means wide variety of data you are going to collect from these persons, energy manager or the production or plant manager of that facility. Then familiarization with the process and plant activities. So you don't know what they are doing. So you are getting familiarized with their process, how they are working, and the first-hand observation and assessment of current level of operation and practices. Then introductory meeting. Step 2 in the detailed energy audit is introductory meeting with all the divisional heads and person concerned with the energy management for 1 to 2 hours. So what are the reasons here or purpose of doing this introductory meeting? So to build up with the cooperation and rapport. So you are going to do audit there for 8 days, 3 days, 4 days. So you need to get the cooperation. You need to get the data from them. So you need to make the proper rapport with those people. So if you get the introductory, you take the introductory meeting with those persons, then you can build this rapport and cooperation. Then orientation and awareness creation, and the issue questionnaire tailored for each department. So this is very important point. So you need to, after the walkthrough audit, you are knowing the basics about that industry, about that facility. So you can prepare the questionnaire yourself, and you can present that questionnaire to the heads, divisional heads or the departments when you are meeting them for the introductory meeting. Then step 3 is the primary data gathering, process flow diagrams and energy utility diagrams. So historic data collection and analysis for setting up the baseline energy consumption, what they are consuming now. All the service utilities systems diagram, that means single line power distribution diagram, water, compressed air and steam distribution. Prepare the process flow charts, design operating data and schedule of operation, annual electricity bill and energy consumption pattern. So annual electricity bill consumption analysis is the next part of the your report after the executive summary. With charts and graph, you are presenting your annual electricity consumption, and it's of what you can say, it's of major importance. Electricity bills of 12 months. Everyone is looking at the cost which they are paying for the electricity. So this part is very important in the report. The next step is step 4, conduct survey and monitoring. So measurements, motor survey, insulation, lighting survey, etc. with portable instruments for operating data. Confirm and compare operating data with the design data. Design data, you can get it from their nameplates, from the nameplates of the motors or the pumps, or the design data may be available with the facility person or the production manager or the energy manager. So you can collect the design data from them, and operating data you are collecting with the help of instruments, various instruments. So at the end of this chapter, there are various instruments which are used for measuring various parameters in the industry. So next step is step 5, conduct of detailed trials. You are taking the trials and tests. That means 24 hours of power monitoring. Maximum demand, power factor, units consumption, harmonics. You can collect it with the help of power analyzer, 3-phase or single phase, load variation trends in pumps, fan compressor, etc. Then boiler efficiency trials, furnace efficiency, or many other equipment efficiency. So conduct of detailed trials means you are now taking the efficiency test of various equipments. You are now collecting the power consumption data of various equipments. Okay. Now the step 6, analysis of energy use. So energy and material balance, energy lost or waste analysis. Once you are done with this step 5, conduct of detailed trials, you get to know about the energy and material balance. You get to know energy efficiency, where the losses are happening. So after step 5, analysis, that means you are now calculating the energy efficiency. You are now calculating the various with the help of various formulas, the specific energy consumption. So thereby you are getting the various losses and wastes which are present in the facility, in the process. Now step 7, identification and development of energy conservation opportunities. So once you are done with this analysis, here in step 5, you are conducting detailed trials, collecting the actual data from the site. Now in the step 6, you are analyzing the data collected from the site. That means you are calculating the efficiency of various equipments, furnace, boilers, whatever. And in the step 7, you are identifying the various energy conservation opportunities, where they are. That means conceive, develop, and refine ideas, review ideas suggested by unit personnel. You can suggest on ENCON is energy conservation measures. So energy conservation measures you only share when you have the energy efficiency data of any equipment like boiler or furnace. So you are first analyzing, first formulating all the energy efficiencies. Then you are developing or you are finding out the solution. If the motors are having very low efficiency, or boilers are having very low efficiency, then what to do next to improve their efficiency, right? So you are having some ideas, some measures. So you are writing it down, all those ideas, and you are reviewing these ideas with the unit personnel, with the heads of every department. Okay. So review ideas suggested in the previous energy audit report, if any. If they have any previous energy audit report, if they have done energy audit previously, and there are some suggestions. So you must review the suggestions given by the previous energy audit report, and then you can incorporate your energy conservation measures and opportunities there. Okay. Then use brainstorming and value analysis techniques. Contact vendors for new or energy efficient technologies. So what is new in the market? If you are suggesting them to retrofit something, then what is the new technology? So you can include it in your report. Step 8 is cost benefit analysis. So assess the technical feasibility, economic viability, and prioritization of ENCON options for implementation. If you are providing some measures for energy saving and energy efficiency, so that must be economically feasible. First, technically feasible, economically viable, and what should be the priority? Okay, where it needs the most. So that should be included in your energy audit report with the priorities. So we have that point also in the next part. What should be the priority in energy conservation measures? What are the priorities? Okay. Then step 9 is reporting and presentation to the top management. After discussing all these things, you are documenting a draft report, energy audit report, and it is presented to the top management of the facility or the industry. And the final report preparation on the feedback from the unit. After discussion and after presentation with the management, final report is submitted. Now, phase 3 of the audit is the post-audit phase, and the step 10 is implementation and follow-up. So you have given them the energy conservation measures, suggested some retrofits or suggested some energy conservation measures to them. Then you need to check on them whether they are implementing those energy conservation measures. What are the action plan? If they have already installed or retrofitted what you have suggested, then you need to monitor whether it's what is its benefits, whether they are getting the benefits from this retrofit or not. So here it is, implementation and follow-up. So purpose is implementation of ENCON recommendation measures and monitor the performance. We just not encourage them to install or implement energy conservation measure. We need to monitor the performance of that energy conservation measures, whether it's operating very well, what is its performance. So here it is, action plan, schedule for implementation and monitoring and periodic review. After a certain time period, you need to review that, whether it's actually saving the energy or not. So phase one, again, pre-audit phase. Just a minute. So phase one is pre-audit phase. An initial study of the site should always be carried out as proper planning is a prerequisite for an effective audit. An initial site visit should take only 1 day and gives the energy auditor an opportunity to meet the personnel concerned, to familiarize with the site and to assess the procedures necessary to carry out the energy audit. It's already mentioned in here. If you look at here, phase one, pre-audit phase. So you are familiarizing with the process. This is the phase one, pre-audit phase. So they have explained here only that. So during the initial site visit, energy auditor or energy engineer should carry out the following actions. So discuss with the site senior management about the aims of the energy audit, why they are wanting energy audit, because they know much better about their processes. So what they are thinking about that and why they need the energy audit. Explain the purpose of the audit and indicate the kind of information needed during the facility tour. Right? We need to ask them. Please give us your base data consumption, your energy bills for the 12 months, your SLDs and your piping diagrams, your distribution diagrams and everything. Discuss the economic guidelines associated with the recommendation of the audit. Analyze the major energy consumption data with the relevant personnel and obtain the site drawings and everything. So we have already seen these points. So what is the outcome of phase one? This is the phase one, pre-audit phase. So after doing this, what you get to finalize the energy audit team? So the energy audit team is different for different industry because someone is specialized in boilers, someone is specialized in sugar industry, someone is specialized in cogeneration. So you need to finalize your energy audit team depending on the facility or depending on the industry, which type of industry is it. To know the expectation of management from the audit, what they are wanting. It's very important. Because if we are conducting energy audit and we are doing more, we are focusing more on the boiler, but they want some suggestions and energy conservation measures for the lighting and diesel generator and for the furnaces. So in the pre-audit phase, we need to understand why they want the energy audit, what we should focus on, more focus on. Then to identify the main energy consuming areas or plant items to be surveyed during the audit. To identify the existing instrumentation and additional metering required prior to audit. For example, measurement of electricity, steam, oil, or gas. Yes, pre-audit phase is very important because if you are going for energy audit to the site, then you must be ready with every equipment which the facility requires. To plan for the audit with time frame. How much time will it going to take? That means for 8 days, for 4 days, 3 days, 10 days, whatever. To collect the macro data again vast data of the energy consumption, baseline consumption, major energy consuming equipments. To build up awareness and support for detailed energy audit. So build up awareness in the working in the departments, various departments in between the engineers, and get their support for the detailed energy audit. Now, phase 2 of the detailed energy audit is detailed energy audit phase. Now, you are in detailed energy audit, you are at the facility and taking the readings and analyzing the things. So, depending on the nature and complexity of the site, a detailed audit can take from several weeks to several months to complete, right? So, you will get an idea by pre-audit, from the pre-audit phase, how much time will it going to take. So detailed studies would involve investigation and establishment of material and energy balance for specific plant departments or process equipment. Whenever possible, checks of plant operations are carried out over extended period of time. At night and at weekends, as well as during normal daytime working hours, to ensure that nothing is overlooked. So at different period, different time slot, their energy consumption may be different. So as per the requirement, you need to check when you are going to take the readings, when you are going to install the meters there. So the information to be collected during the detailed audit includes sources of energy supplies, from where they are taking the energy. That means electricity from the grid or self-generation, whether they have renewable energy plant, co-generation plant. So this information is very important. Then energy cost and tariff data. So this energy cost and tariff data you can get from the electricity bills or the energy invoices, which you get from the best data or pre-audit phase. Then generation and distribution of site services. Example, compressed air, steam, water, chilled water. Then process and material flow diagram, how the process goes on, how the process works there. Then the material balance data, that means raw material, intermediate and final product, recycled material, use of scrap or waste products, production of byproducts for reuse in other industries, etc. Then energy consumption by type of energy, by department, by major process equipment, by end use. That means energy consumption means whatever that what is the type of energy, electrical energy, thermal energy, that means steam, or what type of energy you are going to use. Then review of ongoing energy management procedures and energy awareness training programs. If they are having already implemented some energy management procedures and they are taking some energy awareness training programs, then you need to review those, what they are, how they are training their employees, how what are the contents of their training program, that you need to review. Next is energy audit team should ensure the following baseline data are collected. Quantity and type of raw material. What is the raw material and how much is the quantity? Technology, process used and equipment used. Capacity utilization, efficiency or yield. Percentage rejection, reprocessing. Quantity and types of waste. Consumption of fuel, water, steam, electricity, compressed air, cooling water and chilled water. Hello?
Yeah, ma'am. How the quantity can be related with energy audit of
Quantity of,
raw materials?
because you are processing that raw material in the process. So to process that raw material, you require energy.
No, but it will not hamper directly, no? So whatever the
But
product they are manufacturing, so I think they are aware of the detail of that products. So it will not correlate with energy audits as per me.
no. Actually, you are processing raw material, and for that you require energy. That means you are utilizing energy in processing that raw material. So whenever you are doing detailed energy audit, so you need to check each and every point. That means raw material also.
Okay.
Yeah,
Thanks.
your point is correct, because you are thinking from outcome. That means output based, right?
Yeah,
That
yeah.
means specific energy consumption, whatever the output is, and what is to produce that output, how much is the energy consumption, right?
Right.
Yeah, but to get to that output, you first process the raw material or input. So that's why we need to consider that also.
No, that industry expert is aware what he is using the basics for that product, right?
Correct, but
So the machine design is as per the raw materials only.
then that is correct, sir. But if you are, for example, if we take the example of boiler, then the raw material used maybe briquettes or what you are using. Uh, what is the raw material used for that boiler? It hampers the efficiency of boiler, sir, basically.
No, it's a standard process no, of that industry that what
Standard,
are.
but yeah, but you can
Suppose I am
suggest
using a
them.
chiller. Take a example. Suppose I
Okay.
am using a chiller for air conditioning. Okay.
Hmm.
So I know that the chilled water parameters are 7 and 12 degrees Celsius.
Hmm.
Chilled water out will be 12, in will be in will be 12, out will be 7.
Hmm.
So how you can analyze the raw material in that case?
In that case, raw material is not there, sir. If you are taking any process industry, then you need to check. Or just now, what I have given the example is the boiler. So in case of boiler, it hampers the efficiency. What is the input you are providing? Its calorific value. It hampers the efficiency of the boiler. So that's why they have mentioned here the quantity and type of raw material used.
Okay.
So you need to
I think
collect that data.
it's correlated with manufacturing, I think.
Yeah,
So I heard.
yeah. Correct.
Okay, thank you.
Yes. Then preparing the process flow diagram. So it's again, you can take the flow chart of the process. So they have given here the penicillin G fermentation. So the idea here is what is the raw material, what is the input you are going to give the process, and what the output you are getting. So the basic idea of this diagram or the flow chart for any of the what you say process is that whatever the input you are giving and what the output you are getting. Then okay, identification of NCON opportunities. So first is fuel substitution, identifying the appropriate fuel for efficient energy conversion. Then yeah, here it is fuel substitution. So what fuel you are going to use for the furnace or for the boiler, uh, that need to be identified, and there may be the opportunity for energy conservation. Energy generation, identifying the efficiency opportunities in energy conversion equipment, utilities such as feasibility of for high efficient DG sets, optimal loading of DG sets, and then the boiler optimization, minimum excess air combustion with boilers, and optimizing existing efficiencies and all, cogeneration, biomass gasifier, etc. Then energy distribution, identifying the energy efficiency opportunities in electrical systems such as transformers, cables, switch gears, and power factor improvement in electrical systems. So all these, in case of electrical systems, um, the value of power factor you can get even in the electricity bills if it is industrial consumer. Then and you can suggest them for the energy, what you can say, for conservation measures with that. Energy usage by processes. So this is where the major opportunity for improvement lies. Uh, Many of them are hidden. Process analysis is a useful tool for process integration measures. Yeah, then technical and economic feasibility. So the technical feasibility should address the following issues. So technology availability, space, and skilled manpower. Whatever you are going to install or what suggestions you are going to do for the energy conservation, then technology availability, space, and skilled manpower, these 3 points are very important. The impact of energy efficiency measure on safety, quality, production, or process, reliability, service issues, maintenance requirement, and spares availability. That means whatever suggestions you are going to give after the audit, that must be technically that equipment or that measure should be reliable, and there should not be a service issue or maintenance requirement, or spares are easily available for that. Then the economic viability often becomes the key parameter for the management acceptance, because cost is the major issue, and the economic analysis can be conducted by using payback method. So everyone is going to ask us what is the payback period, what is the rate of return, internal rate of return, IRR, or net present value method, and all. So for low investment, short duration measures which have attractive economic viability, payback method is sufficient. Sorry. A sample worksheet for assessing the economic feasibility is provided below. So first block is investment, annual operating cost, and annual savings. So net savings per year is nothing but the annual savings minus annual operating cost, and the payback period is nothing but investment divided by savings. So this formula is very important because in exam, there is a question based on this simple payback period. You need to calculate the payback period for any energy conservation measure. So investment may be equipment, that means you are retrofitting something, or you are installing new equipment there. Then for that purpose, you need some civil works or instruments, you need to install some sensors or new instruments. Then any auxiliary equipment is required. This is your investment. Annual operating cost is nothing but cost of capital. It's maintenance, manpower. If you are installing something very delicate and sophisticated, you need the skilled manpower, then the cost, it is the cost in the annual operating cost. Then energy required and the depreciation. So this is the operating cost, and saving in terms of thermal, electrical, raw material, and waste disposal. So the classification of ENCON measures are low cost, high return, medium cost, medium return, high cost, high return. So there are three types categories of the ENCON measures. So low cost, high return, this category is more preferred because investment is low and your returns are high. So normally the low cost, high return projects receive priority. Other projects have to be analyzed because the investment is more there. So they need to be analyzed, they need to be approved, and then they are installed. So other projects have to be analyzed, engineered, and budgeted for implementation in a phased manner. We cannot install them directly, completely, 100%. They are installed in step by step or phase manner. So projects relating to equipment and process changes almost always involve high cost coupled with high returns, and required careful scrutiny before funds can be committed. So project priority. So project priority A, B, C, and D. A is good because it is economically feasible, technically technology is adequate, and there is no risk. So if the priority, if any ENCON measure got the priority A, that means it is economically feasible, technically feasible, and risk is very low. So you can go with that. B, priority B, it may be so well defined and only marginally acceptable economically. Technical feasibility, existing the technology but needs to be updated, or lack of confirmation in the market. So there is some risk in installing this. So maybe we can go with these energy conservation measures. C, priority is on held, poorly defined and marginally unacceptable economically. Existing technology is inadequate and risk factor is there. D, priority is least priority on the risk. No, clearly not attractive, need major breakthrough and not feasible. So economically it is not attractive. So D is the least. If any ENCON measure got the D priority, that means it is having very least priority. We are not going with that. The next is energy audit report. After conducting the energy audit, what should be the format of that of the energy audit report? So the length and details of the energy audit report will depend upon the facility audited. It depends on facility, how much equipments you are going to audit, analyze. So it depends, the length of that report depends on that. The report should begin with an executive summary. We discussed it earlier in the chapter that your first is nothing but the executive summary. Executive summary is nothing but you are providing them the energy conservation measures from your observations, from your analysis, from your study, along with their investment and their payback period. These are included in the executive summary. That means in executive summary, you are including energy conservation measures, what you have observed, then the investment required to install those energy conservation measures, and then the savings and the payback period for that particular energy conservation system measures. The management of the audited facility will brief the synopsis. Okay, total savings and highlight each energy saving measure. Yeah, they have given the downside also. The main report should start with general description of the process or facility. You are giving what the facility is, what is their production, what is their flow, process flow. Then the annual energy consumption and bills should be presented, correct? First, you are going with the executive summary. Then you are describing their process which is happening in the facility. Then the annual energy consumption and bills should be presented with tables and graph. You need to present in the report 12 months of electricity bills along with their maximum demand, power factor, everything with their tariff, and you need to present their consumption with tables and graphs. This should be followed by description of energy inputs and outputs by major departments or by major processes and evaluation of efficiency of each step in the process. Then recommended ENCON measures should be presented with calculations for cost and benefit along with the expected payback on any capital investment. The audit report should conclude with the specific recommendation for detailed engineering studies and feasibility analysis, which must then be performed to justify the implementation of those conservation measures that require high investment. So you need to justify why you are suggesting these energy conservation measures. And after installation or implementation of these energy conservation measures, what are their returns, what they are getting back. Regardless of the audience for the audit report, it should be written in clear, concise, and easy to understand format and style. So everyone is not with the technical background, so you need to be very clear. So that's why executive summary is very important in any energy audit report because it shows the economic feasibility and viability of the suggested measures. So this is a report on detailed energy audit. What should be there? So acknowledgement, energy audit team, executive summary. This is the first part. Then introduction about the plant. So plant description, components and their flow chart. Then production process description. Then energy and utility system description. So brief description of each utility. That means electricity, steam, water, compressed air, chilled water, cooling tower. Then detailed process flow and energy and material balance, flow chart showing the flow rate, temperatures. Then energy efficiency in utility process and process systems. So specific energy consumption is very important. Boiler, if facility has boiler, then boiler efficiency assessment, thermic fluid heater performance assessment, furnace, cooling tower, DG sets, AC, refrigeration, HVAC systems, compressed air, electric motor load analysis, and lighting system. Last one is the lighting. So whatever is present in that facility, you need to include here. So energy efficiency, you need to calculate energy efficiency of each and everything which is present in the facility. Then energy conservation options and recommendations. So executive summary, you are combining the energy conservation measure with its finances. That means how much investment is required to install that particular energy conservation measure, when you will get your invested money back, that means payback period. And last one is the energy conservation options recommendation with their justification. So you need to justify here. The following worksheet can be used as guidance for energy audit. So this is the summary of energy saving recommendation. is the energy saving recommendation. Suppose you mentioned that you need to replace all your CFLs with the LEDs, all the conventional fans with the VLDC fans. Then the annual electricity saving, how much you are going to save, that you need to write down in this column. Then the annual cost saving, how much you are saving. For example, if the BLDC fans, the wattage rating varies from 25 to 35 watts. The conventional fans wattage is more than 70 or around 70 and 80. So you are around 40 watts, 30 to 40 watts you are saving. So how much you are saving in terms of cost of electricity. Then the capital investment, if you want to replace your conventional fan with the BLDC, what is the price of that particular fan, and how much is the investment, and this payback period. So payback period is nothing but the investment, whatever you are capital investment doing on that energy conservation measures, divided by how much you are saving. You will get the simple payback period here. So in the examination, simple payback period examples are also coming, even in MCQs, I think. I will mark the MCQs, which are very important, and then share it with you. So next is types and priority of energy saving measures. So no investment, that means immediately by changing your actions and by taking care by the employees and workers, you can save the energy. Then the operational improvement and housekeeping. Then low investment, that means investment is very low. You can install any controls or any sensors, equipment modifications, and process change. High investment means energy efficient devices. You need to retrofit high energy efficiency devices, product modification, and technology change. So these are the type of energy savings, A, B, and C. Now the phase 3 of the post audit, phase 3 of the detailed energy audit is post audit phase. So on the completion of energy audit, energy action plan should be prepared. The energy action plan lists the NCONs which should be implemented first and suggest an overall implementation schedule. So after completing the energy audit, you are submitting the energy audit report. You are presenting the draft report in front of the management, and then you get it approved after the discussion, and you are submitting the final report. So after the final report, that means post audit phase, the energy action plan list, that means energy conservation measures which you included in the executive summary, should be implemented first and suggest an overall implementation schedule. So you need to prepare the schedule for the implementation, what you have suggested to them. So energy audit is incomplete without monitoring and its associated feedbacks. Monitoring consists of collecting and interpreting the data. After installation of the energy conservation measure, whether you have provided the energy conservation measure based on your analysis, based on your calculations, and once the energy conservation measures are installed, you need to continuously monitor that installation. That means whether it's feasible, whether it is viable, whether it is really saving the energy and thereby money. So you need to check it. That means you need to monitor and it associated with the feedback. Monitoring consists of collecting and interpreting the data. The data to be collected depends upon goals chosen in the energy action plan. Electrical power consumption and fuel consumption must be evaluated and monitored. The monitoring data should provide direct feedback to those most able to implement the changes. Often, additional instruments should be installed in various departments in addition to main metering. Monitoring should result in more action. Good practices should be replicated. If the gap between planned objectives and actual achievements should be initiated, and results should be monitored in this way. Analysis, action, and monitoring are a cyclic process. First, analysis, then action, that means you are implementing, and then monitoring, that means whatever you have implemented, you need to monitor that, so that you will get to know whether it's really economically feasible, viable, or not. It's really saving the money and energy or not. So the reporting format for the energy conservation recommendation. So this is the recommendation which you have provided. Here they have given one example. So the title of recommendation, combine DG set cooling tower with main cooling tower. Okay. So the description of existing system, what they have in the operation. So main cooling tower is operating with 30% of its capacity. The rated cooling water flow is 5,000 meter cube per hour. 2 cooling water pumps are in the operation continuously. Okay. With 50% of its rated capacity, a separate cooling tower is also operating for DG set operation continuously. So there are 2 cooling tower, main cooling tower and for the DG set. Now your recommendation is combine the DG set cooling tower with the main cooling tower. You are suggesting them that you need not require separate cooling tower for the DG set. So the description of proposed system. The DG set cooling water flow is only 240 meter cube per hour. By adding this flow into the main cooling tower, that means your main cooling tower is operating only with 30% of its capacity, total capacity. So by adding this flow into the main cooling tower, will eliminate the need for a separate cooling tower operation for the DG set, besides improving the percentage loading of the main cooling tower. Already your main cooling tower is only operating for 30% of loading. You are just shifting your DG set cooling tower load of 240 meter cube per hour to the main cooling tower. So this improves the percentage loading of the main cooling tower, and it is suggested to stop the DG set cooling tower operation. So here is the energy saving calculation for this scenario. So the capacity of the main cooling tower is 5,000 meter cube per hour, and the temperature across the cooling tower design, that means it's 8 degrees centigrade, and the present capacity is 3,000 meter cube per hour. The temperature across the cooling tower, operating value of the temperature is 4 degrees centigrade. So percentage loading of the main cooling tower is 3,000 into 4, 3,000 its present capacity, divided by 5,000 into 8, it's 30%. It's already given, so you need not to calculate it again. They have calculated. So capacity of the DG set cooling tower is 240 meter cube per hour, and the temperature across the tower, cooling tower of the DG set is 5 degrees centigrade. So heat load of the cooling tower of the DG set is 1200 kilocalories per hour, right? So heat load is nothing but that means MCP delta T. It's the formula for calculating the your heat load. So here what 240 is meter cube per hour. So you need to convert it into the kg per hour. So 240 into 1000. CP is nothing but the specific heat of the water, and 5 is the delta T is nothing but the temperature at the cooling tower, DG set cooling tower. So you get this value. So the number of pumps. So there are 2 pumps. They have already given there. Here they have written 2 cooling water pumps are there in operation continuously. So number of pumps and rating. There are 2.
Madam, in MCP delta T, what is the one?
CP. It's the specific heat.
Specific heat. Okay.
Of the water. Yeah.
Okay.
I just want to say that every problem which is present in any book, whether it is first, second, third, or fourth, every problem has equal importance, because in the question paper you will find out the similar pattern of the question, similar problem. Only the values are going to change. Okay, I can show you. I already have that. So I suggest yes.
It's 240 into 1000.
The 240 is meter cube per hour. So
Yeah,
you need to
barabar.
convert it into kg per hour. So that's why you need to multiply it with 1000
Okay.
to get kilocalorie per hour heat load.
Okay.
Okay. So every problem is equally important, because in examination they only changes the values. Sometimes the part of this can be asked in MCQ also. So what I will do, I will mark the questions which are related to this chapter, chapter 4, and I will send it to you all. So it will be easy. So number of pumps, there are two number of pumps, 7.5 each of 7.5 kilowatts. Number of fans, there are two number of fans there for cooling tower, two numbers and 22 kilowatt each. The power consumption, that means they are operating at 80% of their capacity. So you need to multiply 7.5 into 2 plus 7.5 into 2 plus 22 into 2 into 80%. It is taking a load of 80% only. So that's why if you multiply these two and add these two, you will get 47 kilowatts. Okay. So the additional power required for main cooling tower for additional water flow. This is the power required by the main cooling tower, which is already they have. Okay. Now the power required for this flow, DG set cooling tower. They have two cooling tower. One is main and another is DG set cooling tower. So DG set cooling tower has the volumetric flow of 240 meter cube per hour only. So you are shifting this 240 meter cube per hour load or flow, volumetric flow to the main cooling tower flow, right? So to add this 240 meter cube per hour, what is the power required? So this is 240 meter cube per hour. If you convert it into liters per second, why we are converting it into liters per second? Because if you multiply the liters per second volumetric flow rate into the pressure, you will get the hydraulic power for that pump. So that's why we are converting 240 meter cube per hour into 66.67 liter per seconds. Okay, 1 meter cube per hour is nothing but 0.2778. I will provide these values or solve example in the mail. I will share it. I have this solved example. I will share this with you. So they have only converted 240 meter cube per hour into 66.67 liter per seconds, multiplied by 6 and divided by 0.55. Here they haven't mentioned the what is 0.55 and what is 102. So 0.55 is nothing but the efficiency. You are dividing this hydraulic power divided by efficiency so that you will get this get the power which is required to make the flow of 240 meter cube per hour. This is the flow requirement of the cooling tower of the DG set. Okay. So this is coming to 7 kilowatts. So what is the total power or net energy saving you are getting? Actually, what is happening? For total is 47 kilowatt you are spending, and 7 kilowatt on 7 kilowatt is the power consumption of the DG set cooling tower. So you are saving the energy or the power consumption by 7 kilowatts. That's why they here subtracted 47 minus 7, you will get 40 kilowatt of net energy saving. So annual energy saving potential is 40 kilowatts. Now here they have considered directly. This is the 8400 is the operating hours of that cooling tower. So 8400 hours per year. Okay. So 40 kilowatts into 8400, it gives you kWh units, electricity units per year. They have considered 4 rupees per unit you are paying the cost to the DISCOM. So 3,36,000 into 4, you will get 13.4 lakhs. The investment, only the piping is required. That means you need to just redirect the piping from main cooling tower instead of DG set cooling tower. So it takes 1.5 lakhs. So if you observe here, the investment is 1.5 lakhs and your annually saving is 13.4. That means less than within less than 2 months you are getting your investment back. So simple payback period is less than 2 months. That means you need to just invest divide 1.5 divided by 13.4. You will get your answer. It's in year. You need to convert it into months. Okay. You can take it as a you can mention it in the years also.
Madam, on this thing, madam. So
Okay.
actually, 102 into 0.55, how it has come, madam?
Yeah, 0.55 is the efficiency of the pump.
Okay, ma'am. 102, madam.
Yeah.
102.
102 is the conversion factor used here. They haven't
Con-
specified anything here to convert it
Conversion.
in terms of
Okay.
kilowatts.
Acha, kilowatts. Acha, in terms of kilowatts. Acha.
Oh, yeah. They haven't mentioned. You will find many of the problems in all the books. They haven't mentioned what are the conversion factors they have taken, but they are there. So we need to check what is this. So you will get this 0.55 hydraulic power values in, I think, pumps. It's in third book, third
Mhm.
book,
Okay.
pumps. Yeah. So all
Okay.
the 4 books are interrelated. So you will get everything in all these 4 books only.
Okay, ma'am. Thank you.
Yeah. So this is this kind of examples they can ask in the examination, cost benefit analysis. There is one another in the last page I will show you. So this is the first, then understanding energy cost. So contrary to common belief, energy costs are not a fixed overhead. There is often a huge potential for making savings. Understanding the energy cost is vital factor for awareness creation and saving calculation. I think energy cost is also asked in one examination. So we need to focus on this. So understanding energy cost is vital factor for awareness creation and saving calculation. In many industries, sufficient meters may not be available to measure all the energy used. In such cases, invoices for fuels and electricity will be useful. The annual company balance sheet is the another source where the fuel cost and power cost are given with the production related information. So energy invoices can be used for the following purposes. They provide a record of energy purchased in a given year, which gives a baseline for future reference. Energy invoices may indicate the potential for saving when related to production requirement. When electricity is purchased on the basis of maximum demand tariff, they can suggest where the savings are most likely to be made, and in later years, invoices can be used to quantify the energy. So if you have the energy bills, electricity bills, from that also you can check where the energy consumption is more, whether their maximum, what is their maximum demand, whether their power factor is within limits, because there are incentives and penalties for the power factor. So you need to analyze the energy cost there in case of, not only in case of electricity, but in case of any other fuels. Fuel cost. The fuels available for thermal energy supply, fuel oils, low sulfur heavy stock, LSHS, light diesel oil, liquefied petroleum, LPG, coal, lignite, wood, etc. So understanding the fuel cost is fairly simple, and it is purchased in tons or kiloliters. Like in electricity, it is in kWh, it is in tons or kiloliters. Availability, cost, and quality are the main 3 factors that should be considered while purchasing. The following factors should be taken into account during the procurement of the fuels or energy efficiency and economics. So price at source, transport charge, type of transport, quality of fuel, and the energy content. That means calorific value. Quality of fuel means contaminations, whether there are any contaminations. Quality of fuel, not only in case of fuel, but in case of electricity also, you need to check for the harmonics present in the supply, because they are not recommended in the supply to get your working very smooth. So quality of fuel, not only the fuel oils, but in case of electricity also. Then the power cost. Power cost means electricity price. Its power cost varies in India from state to state, city to city also, consumer to consumer also, because we have various categories of the customers, consumers of the electricity. So maximum demand charges, that depends on kVA. Energy charges, maximum demand charges are not applicable to the residential category consumers, but for industry and commercial, they have energy charges, kWh, then TOD charges, time of day tariff, peak or non-peak periods. There are time zones. In case of Maharashtra, there are 4 time zones in which the consumption, that means peak hours and off-peak hours, they have divided. So if you are using energy in the night hours, you will get incentives over that, because those are not the peak hours. So TOD means time of day tariff. In different time periods, if you are consuming, you are getting different rates for those time zones, time of day. So power factor means you can get the incentives and penalties for maintaining the power factor. Other incentives and penalties applied from time to time. High tension tariff and low tension. Yeah, again the category is divided. Sorry. HT consumers and the LT consumers. Slab rate, cost and its variations. So slabs, unit slabs, kWh. So 0 to 100, the slab rate is different. 101 to 300, the slab rate is different. So these are nothing but the slabs in the power cost. Then type of tariff clause and rate of various categories such as commercial, residential and industrial, government, agricultural, right? Then tariff rate for developed and underdeveloped areas and states, and tax holiday for new projects. So electricity duties and other taxes. Next is benchmarking. So this is very important. So if you have books, you can mark it. Benchmarking can be asked as a short answer question for 5 marks. So as Chavan sir told in the inaugural function, for the 5 marks, you just need to write 5 to 7 lines only. Just a point. What is important? You need not require to write down whole page for the 5 marks, because it's time consuming also, and they are just going to check whether you are writing the correct points related to this concept or topic. So the benchmarking can be useful tool for understanding the energy consumption patterns in an industrial sector and for taking measures to improve energy efficiency. So energy benchmarking for industry is a process in which the energy performance of an individual plant or an entire sector of similar plants is compared against a common metric that represents standard or optimal performance. So you are comparing with something. Benchmarking is nothing but you are setting some target and you are comparing. Okay. So it may also entail comparing the energy performance of a number of plants against each other. Since the benchmark tool is used for comparison across the number of plants or sectors, there are 2 important features they should have. First, because they are applied to plants or sectors of different sizes and outputs, the metric used should be common irrespective of the plant size. The most common metric used in energy is energy intensity, which measures energy use per unit of the output. How much energy you are using per unit of output. That means specific energy. Like, second, the tool should be used in a wide range of facilities so as to compensate for differences in the production at similar facilities. Sorry. So here it is, benchmarking forms the basis for monitoring and target setting. The industrial benchmarking programs. There are 3 approaches for energy benchmarking. The first approach is to evaluate an entire industrial sector such as iron, steel, aluminum, cement. This evaluation is used to answer the following questions. How well is this sector performing compared to how it would perform using the best available technology? How well it is performing compared to the same sector in the other countries? Okay, industrial benchmarking. Same sector from different country. With the available technology, how well the sector is performing. Has the sector been improving over time? Has it improved over the time? The second approach is the comparison of individual plants within the sector. A benchmark type indicator is calculated for all the facilities within a sector so that they can be compared on even terms. This evaluation can answer the following question. What is the state of the art performance in this given sector? Just a minute. This external benchmarking relates to inter-unit. This point is very important. External benchmarking. It's in MCQs. Okay. So I will first finish this part and then we will discuss this. What is the state of the art performance in this given sector? How does my plant compare against the state of the art? How does it compare against the majority of other plants in the same sector? In developing benchmarks at the level of individual plants, the issue of proprietary data becomes important. So individual companies are very reluctant to disclose the information about their production process, particularly if it will be released to their competitors. So it is important that the indicators developed are general enough not to reveal any proprietary information. So the external benchmarking relates to the inter-unit comparison across a group of similar units to identify the best practices. However, it would be important to ascertain similarities, as otherwise findings can be grossly misleading. Few comparative factors which need to be carefully looked into while external benchmarking: scale of the operation, vintage of the technology, raw material use specifications and quality, and product specification and quality. That means if you are comparing with one facility with its competitor, you need to external benchmarking, you need to compare based on the scale of the operation, vintage of the technology, raw material specification and quality, and product specification and the quality. Again, here is steps in energy conservation benchmarking. Okay. The steps in energy conservation benchmarking are the identifying the best available technology for the individual process units, collect the information to thoroughly understand the process, determine the performance of the process unit, analyze the gap between existing and benchmark for the key controlling parameters. Set the targets or benchmarks keeping constraints in view, and implement the improvements based on the findings. Now, next is the benchmark parameters. So this is important because one MCQ is there. At the end of the chapter, there is one MCQ. So the benchmark parameters for various sectors, okay, gross production related benchmark parameters, kilowatt hours per metric ton of the clinker or cement produced, that means for the cement plant. Kilowatt hours per kg yarn produced, textile industry. kWh per MT, kilocalorie per kg paper produced, paper plant. Kilocalorie per kWh power produced, heat rate of the power plant. Then million calories per metric ton urea fertilizer plant. kWh per metric ton of liquid metal output in a foundry. So what I want to tell is in the MCQs, they can ask you about any of these benchmark parameters. Just a minute. I will show you page number 100. So, one here. Yes, the benchmarking parameter for air conditioning equipment is. Hello?
Yes.
Hello?
madam.
Yes, yes.
Yeah,
Yes.
you are audible.
Okay, if you see at the question number 6, MCQ 6, benchmarking parameters. We just now discussing about these benchmarking parameters. So if you see the question number 6, MCQ 6, the benchmarking parameter for AC equipment, air conditioning equipment is
KW per TR, no?
kW per TR, but kWh actually. It needs to be, there is some
Actually, it's
print
IKW per TR, means whatever the power consumption
consumption.
per TR particular for the area.
Yes, correct. So what I wanted to tell you is they can ask anything from that.
But in benchmarking, they have restricted very small industry because there are hospitality, hotel industry, malls, data centers.
Right.
So they are just focusing the production units only.
Here it is.
Yeah.
Yeah, yes. There are, but in case of if you are you are telling about hospitality and the commercial malls, so air conditioning unit is there. So equipment
No,
and
no, even
utility.
hospitals, multi-tenant buildings where the multiple business are going. So, energy audits are essential for that buildings.
Yes,
So, whatever the benchmarks set are only for production and industry only.
correct. So benchmarks for the equipment and utility related. So KWH, here it is for on
Yeah,
air conditioning plant. KWH per ton of refrigeration. There is a printing mistake there. They only
Hmm.
written KW per ton of refrigeration. So then percentage thermal efficiency of a boiler plant, percentage cooling tower effectiveness, and KWH per Newton meter cube of compressed air, and KWH per liter in diesel power DG sets. So these are the some benchmarks refer to various units, various units there. So
For cooling tower, what is the parameter?
sorry, percentage cooling tower effectiveness.
Effectiveness. Okay.
Effectiveness. Dry bulb and wet bulb temperature difference. So next is energy performance. Oh, it's already 7. Okay. So plant energy performance. Uh, uh, Again, please note these plant energy performance or energy performance factors, and this is very important part. So plant energy performance is the measure of whether a plant is now using more or less energy to manufacture its products than it did in the past. So the measure of how well the energy management program is doing. Plant energy performance is nothing but the measure of how well the energy management program is doing now. So plant energy performance monitoring compares plant energy use of a reference year and the subsequent years, considering production output to determine the improvement and that has been made. So, however, since the plant's production output varies from year to year, it has significant impact on plant's energy use. For a meaningful comparison, it is necessary to determine the energy that would have been required to produce current year's production. So first is production factor. The production factor is nothing but current year's production. It is ratio, current year's production and the reference year's production. Then the reference year equivalent energy use. The reference year's equivalent energy use is the energy that would have been used to produce the current year's production output. So reference year's equivalent reference year equivalent energy use is nothing but the product of reference year's energy use into production factor, because it refers to the current year's production also. Then plant energy performance, it is the reference year equivalent minus current year's energy divided by reference year equivalent. So I just want to show you one example. Energy performance, right? So this point is here. So here they have asked in 23rd exam, calculate the production factor and plant energy performance from the below mentioned data and comment on the result. So they have asked the question based on these formulas only: production factor, reference year equivalent use, and plant energy performance. So we can solve after completing this theory. Then matching energy uses to the requirement. So mismatch between the equipment capacity and user requirement often leads to energy inefficiencies. The designer always considers safety margins while laying specifications for new equipments and leading to oversized equipment. So, sorry, this presents opportunity for the energy manager for matching the equipment capacity with the user's requirement. So some examples are eliminating the throttling of the pump by impeller trimming, installing variable speed drive VFDs, resizing of the pump depending on the heads, then eliminating damper operations, moderating chilled water temperature, recovering energy lost in the control valves, and adopting the task lighting in place of less effective area lighting. So this is the maximizing system efficiencies. So how you improve the efficiency? So eliminating,
Madam,
sorry,
if you remove the dampers, then how the air balancing will be done?
which one?
Eliminating the damper operation in fans by impeller trimming. Even
Right.
also, when you take the pumps or that, the duration is there. So every time the pump has a life, and after using, he will not
Hmm.
perform 100%. So we
Right.
have to so we have to consider that.
What's your point? Please, can you tell me?
You have mentioned that there is oversized design of the equipments.
Yes.
So it's not every time. You have to consider the duration also. So the duration is also factor there.
Yes, correct. It's there, but not every time you are going to use the oversized, because it affects the efficiency of that particular equipment, right?
Okay.
Because it's not loaded completely if it is oversized.
Yeah.
Even in case of pumps, if the heads are not matching, then also the efficiency drops for that pumps.
Yeah,
So
that's fine. You have to precisely calculate the head.
head, yeah.
Yeah.
Then maximizing system efficiencies. It's very same, eliminating the steam leakages, then maximizing the condensate recovery, adopting the combustion controls for maximizing combustion efficiency, replacing pumps, fans, and air compressors if they are not if they are not having very good efficiency, then ensuring the rated electrical parameters at the motor terminals. What are their specifications and what are the actual values you are getting at the terminals? Optimizing the input energy requirements. So after tuning the energy use practices, attention should be given for minimizing the energy input requirements. So maximizing the heat recovery from the waste energy streams, adopting the cogeneration plants for balancing the heat and power requirement, then adopting the cogeneration plants in sugar factories, and adopting cost-effective renewable sources of energy such as solar, wind, and biomass. So we are already doing very much in case of solar. We are already reached about half of our energy use through solar. So fuel and energy substitution. It's basically substituting the existing fossil fuel with the more efficient and less polluting fuels such as natural gas, biogas, and locally available agro residues. Even in Chennai, I think we have run the locomotive on hydrogen. I think I read just now, I think yesterday, news.
Yes,
So
yes.
it's, yeah, so it's a clean energy. So you are substituting the energy. That means to the more clean and green energy.
Yeah.
Right, yesterday only, right? That locomotives run using the hydrogen.
Right.
So the case study example on the fuel substitution. Okay. Here again, they have given the example. So A is the recommendation. So use of agro fuel, coconut chips, in place of furnace oil in a boiler. So this is the boiler input. So description of existing system, a thermic fluid heater with a furnace oil. Now existing system uses furnace oil as input. In the same plant, a coconut chip fired boiler is operating continuously with good performance. So description of proposed system. It was suggested to replace the oil fired thermic fluid heater with coconut chip fired boiler, as the company has the facility for handling the coconut chip fired system. So how the energy is saved? So here they just given us the recommendation. What is the existing system and what's the proposed system? So here is the specification of the old system. So type of the fuel firing, it's furnace oil fired heater. The gross calorific value of the furnace oil fired heater is 10,200 kilocalorie per kg. Average thermal efficiency is 82%. Heat duty is 15 lakh kilocalories per hour. Operating hour of this furnace oil fired heater is 25 days. 25 days in a month for 24 hours. So that's why 25 days into 12 months into 24 hours. So you will get hourly operating hours as, annually operating hours as 7,200. Annual fuel cost is 130 lakhs. 130 lakhs means you are using that heater for 7,200 hours in a year. Its unit cost is 1,800 rupees per hour. So you are multiplying 7,200 into 1,800. So you will get 130 lakhs. Then modified system, that means you are using coconut chips fired heater, whose GCV is 4200 kilocalories. Average thermal efficiency is 72%. Heat duty is 15 lakhs kilocalories. You are maintaining the heat duty constant. You need to do same work with the help of that with that heater. Only the fuel firing is coconut chips now. So annual operating cost is 7200 into 700. It's 50 lakhs. Annual savings, here they don't mention earlier. That means they have considered that 7,200, this is the operating hours. It will remain same for the coconut chip fired heater also. Okay. 700 rupees per hour is the cost of that coconut chip fired coconut chips. So it is multiplied by 7200, you will get 50 lakhs. If you want to calculate the savings, 130 lakhs minus 50 lakhs, total is 80 lakhs. Manpower cost you need to pay, it's 10 lakh in case of coconut chips. So net annual saving is 70 lakhs. Now investment for the new coconut fired heater is 35 lakhs. So simple payback period is investment, that means 35 lakhs divided by 70 lakhs, that means 0.5 years, that means 6 months. So this is how it is calculated, simple payback period here. Then the instruments and metering for energy audit. So this part is very important because here it is in the 23rd paper, they have asked for 5 marks, match the following: fire rate, combustion gas analyzer, psychrometer, stroboscope, and ultrasonic flow meter. You need to match with the quantity which they are going to measure. Okay. Fire rate is used to measure what? Combustion gas analyzer is used to measure what? Psychrometer is used to measure stroboscope, ultrasonic flow meter. Okay. So for just for giving the example, I have opened this 23rd exam paper. So electrical measuring instruments, power analyzer to measure the kVA, kW, power factor, hertz, kVAR, reactive power, amperes, volts. Then fire rate is in this hand bellow pump. Oxygen or CO2 can be read from the scale, and the fire rate employs the well-known or set method of volumetric analysis. You can go through this. Then fuel efficiency monitor. This measures the oxygen and temperature of the flue gas. Then combustion gas analyzer. It measures the various gases such as CO2, CO, NOx, nitrogen oxide, and sulfur. Then manometer with pitot tube. So digital flexible membrane manometer is used for measuring the pressure in air ducts carrying exhaust flue gases for boilers and furnaces. Then contact type thermometer. These are the thermocouples which are which measures the, for example, flue gas, hot air, hot water temperatures by directly inserting the probe into the stream. Then non-contact type infrared thermometers. It is again used to measure the temperature. Then ultrasonic flow meters. So this one of the popular means of non-contact type flow meter. So yes, here it is. So there are two main types of ultrasonic meters: transit time and Doppler. Transit time ultrasonic meters have both a sender and a receiver. So you will get notice. This point is asked in the MCQ, the next, the last, at the end of the chapter. So then speed measurements. Speed measurements using tachometer and stroboscope. It is also asked in the MCQ at the end of the chapter. Then psychrometer. A sling psychrometer consists of two thermometers mounted together with a handle. So One thermometer is ordinary and measures the dry bulb temperature, and the other has a wet cloth wick over its bulb, and it's called the wet bulb thermometer. So when the reading is to be taken, the psychrometer is whirled around, the water evaporates from the wick, cooling the wet bulb thermometer. Then the temperatures of both thermometers are read. By using this psychrometer, these temperatures, the humidity is computed. Then the lux meter is to measure the light. It is a light sensitive cell, measures the incident light. The smart energy meter, so it measures the units consumed, electrical units consumed. And then thermography. So infrared thermal monitoring and imaging, non-contact type, so measures the thermal energy radiation from hot and cold surfaces. So you need to go through all these instruments, what they are used to measure. Then the Bureau of Energy Efficiency, the manner and interval of the time for conduct of energy audit. So every designated consumers are already defined by Bureau of Energy Efficiency. Now they have considered in part 3 cycle, they have considered steel industry also, and also they are appointing some team to deliver or to match or to save the energy in steel industry. Steel, aluminium, textile industry are nothing but the designated consumers. So designated consumers shall have its first energy audit conducted by accredited energy auditor. Accredited energy auditor is the one which is accredited only by BEE after conducting the energy audits at the energy intensive industries. Okay, within 18 months of the notification issued by the central government. The interval of that means once you are a certified energy auditor, you need to do some energy audits and the reports of the energy audits of the designated consumer, energy intensive industries. Then you can get the accreditation from the BEE, Bureau of Energy Efficiency. The interval of time for conduct and completion of subsequent energy audit shall be 3 years with effect from the date of submission of previous energy audit report. So the
Means we have to submit the reports to BEE for accreditation.
Accreditation, yes. If you are a certified energy auditor, you
Okay.
must carry out the energy audit of designated consumers, or you can call energy intensive industries like steel industry, sugar factories, then chloralkalis, chemical factories, fertilizers, then textile industries. Those you need to fill the form with at the Bureau of Energy Efficiency website. Then they schedule, then they check all the reports, then they schedule an interview, and then they accredited that particular energy auditor.
Okay, but after clearing the exam, we can start the energy audits of private firms directly.
Yes, directly. You can do that.
So there is no certification required for further.
Oh, you already getting the certificate of energy auditor from Bureau of Energy Efficiency. So you are eligible to do the energy audits of,
Okay.
yeah, any
But
institute.
madam, as Gandhi sir informed, it required minimum 5 years of the experience.
Yes, 5 years of experience. Yes, for accreditation.
Yeah.
And
Okay.
around 10 reports you need to submit to BEE. 10 or 15. I'm a little bit confused. That means you have to analyze, or you have to audited 10 to 15 designated consumers first, and you have to submit that report to the BEE. Then they check all the reports and get interviewed, and then accredit the energy auditor.
Okay.
Mm. So it's again manner of the energy audit, verification of the data, then scope of energy audit, and collect the energy consumption and production data. It's similar. Monitoring and analysis of the use of energy data for the energy audit. Yes, the accredited energy auditor shall verify the accuracy of the data collected in the consultation with energy manager as per the standard practice to assess the validity of the data collected. So for energy intensive industries, accredited energy auditor needs to sign their report. The preparation of recommendation on energy prioritization and preparation of action plan. Again, priority wise, which measures needs to be in structure of energy audit report. The data collection has been carried out diligently and truthfully, and all the monitoring devices are in good working condition, and the accredited energy audit shall highlight the strengths and weaknesses of the designated consumer in the management of energy and energy resources. So that's it. Just a minute. Yeah. Here is. So here is one solved example. An energy manager in a factory has gathered following data to arrive at the plant energy performance. So reference year of the energy use is 2009, 12 million kilocalories. Production factor of the current year is 0.9. Current year's energy is 11 million kilocalories. What is the plant energy performance of the factory for the year 2010? State your inference. So energy performance, plant energy performance, PEP, we need to calculate. So for that, you need to first calculate reference year equivalent energy. So reference year equivalent energy is nothing but reference year's energy use. That means 2009. It is your reference year. Its energy use is 12 million kilocalories into your production factor is 0.9. That production factor is nothing but current year's energy divided by reference year's energy use. 11 divided by 12, it's 0.932 something. Then 12 into 0.9, you will get 10.8 mega kilocalories, million kilocalories. And the plant energy performance, that means PEP is equals to reference year equivalent, that means this 10.8 minus current year's energy, that means 11 million kilocalories, divided by reference year equivalent. Reference year equivalent again 10.8. So 10.8 minus 11 divided by 10.8, you will get answer as minus 1.85. So reference year equivalent must be greater than that of your current year's energy. Then only you will get answer in positive, plant energy performance. So inference here, what they have written, plant energy performance is marginally negative. So energy manager or plant manager has to take action to improve the performance. Yeah. So I want to show you here. S2, short answer. Calculate the production factor and plant energy performance from the below mentioned data. If you see, it's quite similar. It's just the values are changed. So, and also comment on the result. So reference here energy consumption is 10 million kilocalories. Reference here production in metric tons is 90,000 metric ton. Here in this example, it's very clear. Okay, so current year energy consumption, reference year consumption is 10 million kilocalories. Current year, their energy consumption is 8 million kilocalories. Their reference year production is 90,000 metric ton. Okay, and their current year production is 70,000 metric ton. So here you can clearly observe here also the answer is in negative. Why? Because your reference year production is more compared to your current year production. If you are reducing your energy consumption, that means you are not hampering your production, right? So here production factor is nothing but current year production, which is 8 million kilocalories divided by reference year production, that means 10 million kilocalories. You will get answer of production factor is 0.78. Then reference energy equivalent is reference energy, reference year energy consumption, that means 10 million kilocalories into production factor, that means 0.78. You will get answer as 7.8 million kilocalories. Sorry. Then plant energy performance. So plant energy performance, that means 7.8 minus current year, 8 million kilocalories divided by 7.8. Answer is again negative. Why this is negative? Because of this current year production is less. you are reducing your energy consumption. That means you are not supposed to reduce the production, right? So that's why it's negative. So as the plant energy performance is negative, the plant energy manager has to take the corrective action to improve the plant energy performance. So if it's negative, then energy manager needs to take the corrective action to improve the plant energy performance, PEP. So it's quite similar if you observe both the examples. So Chavan sir already stated that all the examples are quite similar, just values are different. So these are the objective type question. So if you remember at the start, we have read the definition of energy management, the judicious and effective use of energy to maximize profits and enhance competitive positions. This can be the definition of. Hello.
Energy
ma'am.
management.
Yes.
Energy
we-
management.
Yeah. So it's from the chapter only. And if you start reading the previous year question papers, so nothing is out, no question is from outside these books. So second is the role of energy manager is energy auditor and in charge of the finance department of the plant. B, intermediate player between top management, energy and cost centers of the plant. In charge of the captive power plant. What would be the answer? And mediator between the
B.
plant? Yes, correct. Intermediate player between the top management, energy and cost centers, correct. Then third one is the objective of energy management includes minimizing energy cost, minimizing waste, minimizing environmental degradation, all of the above.
All of the above.
Yes, correct. It's already there in the first or second page of this chapter.
Right.
The ratio of current year's production to the reference year production is demand factor, production factor, utilization factor, or load factor.
Production factor.
Production factor.
Production factor, correct. 1 unit of electricity is equivalent to dash kilocalories heat units.
860.
860, yes. That means B is the answer for it. The benchmarking parameter for air conditioning equipment is, you already given the answer. A, kWh per tons of refrigeration.
Right.
Then seventh is, which instrument is used to monitor O2, CO2 in the flue gas?
D.
Combustion analyzer.
Combustion analyzer.
Pyrite. Pyrite is the correct answer.
D.
Pyrometer.
D.
Pyrite.
Yes. Then eighth question is, non-contact speed measurements can be carried out by tachometer, stroboscope, oscilloscope. No, tachometer needs to be connected to the shaft of the motor.
Okay.
Proboscope.
Stroboscope is the
B.
correct.
B. B. no.
Yes, B. Then ninth one is, which one of the following is not considered for external benchmarking? I already highlighted this point. Scale of the operation, vintage of the technology, energy price, and quality of raw material and products. It's the energy price. Energy price cannot be considered as a benchmarking parameter. External. It's the answer for ninth is C. The transit time method is used in which of the instrument? I again highlighted this one. Lux meter or ultrasonic flow meter or pitot tube or Pyrite.
B. B.
Yes, B, correct. Ultrasonic, right. Then the short type answers, explain what is meant by targeted energy audit. Can give you the page numbers for the answer. Okay, I will mark it. I don't have the physical book right now. So I will mark it and share it on the mail or in the drive.
Okay. Yeah.
Yes. In all the long type questions and short type questions are theoretical. It's 23rd paper. Okay. What I will do, I will mark all the important questions and I will share it on the drive.
Is it okay if you share similar numericals by changing the values only?
Sorry?
Numericals
Huh.
by changing the values.
So what you want? I need to share it.
Yeah.
Okay, sure. I will do that. It's very important because only the values are getting changed. Nothing
Yes,
else.
yes. So
Yes.
just we can have practice on that.
Yes. Always refer previous year question papers. Always.
Okay. Okay.
Yes.
Thank you.
Previous
Thanks.
year question papers and the MCQs which are present on at the end of the chapter. Those are very important. Yeah. So will we stop here? Do you
Yeah.
have
Yeah.
any-
Thank you.
Yes.
Yes, madam. Yeah. Thank
Yeah.
you.
Yes.
Thanks a lot.
Thank you.
Thank you, ma'am.
For your attention.
Thank
Yeah.
you.
Thanks a lot.
Thank you very much.
Thank you.